Hi, this is Walter Stone, and we're in Unit 7. This is Lesson 2, and this is called Adding and Subtracting Rational Expressions. And after finishing this lesson, you should be able to add and subtract rational expressions. So the rule here is when we add fractions, we need the same denominator. And if we have the same denominator, we can then add the numerators. So in this example, these two fractions have the same denominator. We have 4x squared minus 5xy over x squared minus y squared plus 2xy minus y squared over x squared minus y squared. Since they have the same denominator, we can add the numerators. So we'll have 4x squared minus 3xy minus y squared if we add like terms. And then we always want to check if we can simplify or not. So we want to factor and cancel if we can. So it turns out that 4x squared minus 3xy minus y squared factors into 4x plus y times x minus y, and the denominator is a difference of two squares. So this factors into x plus y times x minus y. So we have a common factor of x minus y that can cancel, and we're left with 4x plus y over x plus y. So here is a try this problem in your learning guide. Try this problem, come back, and then check your solution with my solution. Okay, so when we are now back, what we can do, because we have the same denominator, we can add the numerators. So we look for like terms. 2x squared plus x squared is 3x squared. Negative 5x plus negative 19x is negative 24x, and 9 plus 4 is 13. And there are no factors of the numerator that cancel with the denominator, so we can leave the fraction the way it is. In our second example, we now want to subtract, and we have the same idea that if we have two fractions and we're subtracting, if we have the same denominator, we can find the difference in the numerators. So here we have 4x plus 5 over x plus 3 minus x minus 2 over x plus 3. We have the same denominator, so we can take the difference in the numerators. So I'm taking 4x plus 5 minus the quantity x minus 2. Notice that I'm wrapping the numerator from the second fraction in parentheses because I need to make sure I'm subtracting correctly. So in this next step, the opposite of x minus 2, that's the same as minus x plus 2. So I want to make sure that I distribute that negative before I add like terms. So 4x minus x is 3x, 5 plus 2 is 7. So the difference in these fractions is 3x plus 7 over x plus 3. No other factors can be canceled in this case, so that's a simplified fraction. Okay, so try this next problem and pause the video and then come back when you're done, and we can take a look at to see if your work matches my work. So here we have 4y plus 7 over x squared plus y squared minus 3y minus 5 over x squared plus y squared. We have the same denominator, so we can take the opposite of the numerator of the second fraction. So I put parentheses around the 3y minus 5. That's really essential to help me make sure I distribute the negative correctly. So we'll have 4y plus 7 minus 3y plus 5. And then we can simplify the numerators. So we have 4y minus 3y is y, 7 plus 5 is 12. So this simplifies to y plus 12 over x squared plus y squared. Okay, so that's what goes on if we have the same denominator. And here we want to talk about a procedure that has us look at finding a common denominator. Because in order to add fractions, we need common denominators. and working with the least common denominator helps us do that. So to find the least common denominator, we factor each denominator completely into prime factors. We list all the different prime factors, and the LCD is a product of these factors, each of which is raised to the highest power that appears on that factor in the denominators. So if we look at the first denominators, x squared plus 5x plus 4, that factors into x plus 4 times x plus 1. X squared plus 2x plus 1 is x plus 1 times x plus 1, which is x plus 1 squared. So now we have prime factors, and we want to take each factor. So the different prime factors are x plus 4 and x plus 1, but there are two factors of x plus 1. So we need to take the highest power that appears on any factor. So we need to take x plus 1 squared. So our least common denominator is going to be x plus 4 times x plus 1 squared. So what if you have these two expressions? What if you have 3 over x squared plus 7x plus 12 and x over x squared plus 8x plus 16? Pause the video and find the least common denominator of these two expressions, and then come back when you're finished and check with my answer. Okay, so x squared plus 7x plus 12 factors into x plus 3 times x plus 4, and x squared plus 8x plus 16 factors into x plus 4 squared. It's a trinomial square. So I need an x plus 3 and an x plus 4, but x plus 4 is raised to the second power, so I need the x plus 4 raised to the second power. Okay, so the least common denominator will be x plus 3 times the square of x plus 4. So now what we want to be able to do is add and subtract rational expressions with different denominators. So if two rational expressions have different denominators, we first need to find the LCD, and we rewrite each fraction as an equivalent fraction that has an LCD as the denominator. So remember, with equivalent fractions, if we multiply a fraction by any form of 1, we get an equivalent fraction. So here for this problem, negative 2 over x plus 2 plus x plus 3 over x squared minus 4, I factored the denominator of the second fraction so that I can figure out what the LCD would be. So the LCD will need a factor of x plus 2, and we'll need a factor of x minus 2. So this first fraction is missing a factor of x minus 2 to get the same denominator. So I'm multiplying the first fraction by x minus 2 over x minus 2. The second fraction is already built up to the LCD, so I don't have to do anything to the second fraction. So to simplify the first fraction, I have to multiply the negative 2 by the x minus 2, and I wrapped the x minus 2 in parentheses to make sure I distribute correctly. So I see now also that these two fractions have the same denominator, so I can add the numerators. So if I multiply negative 2 by x minus 2, I get negative 2x plus 4. I'm adding the x plus 3 from the second numerator, and I can simplify that numerator, so I have minus x plus 7 over x plus 2 times x minus 2. So I built up this first fraction, so I have a common denominator, and then I was able to add the numerators. Okay, so try this problem. Here we want to add x plus 3 over x squared plus x minus 2 plus 2 over x squared minus 1. Okay, so pause the video, try this out, and then come back and check your work. So here what I did was I looked at the denominators. I factored the first denominator to x plus 2 times x minus 1. The second denominator factors into x plus 1 times x minus 1. And for the LCD, I need a factor of x plus 2. I need a factor of x minus 1. And I need a factor of x plus 1. So to build up the first fraction to have this common denominator, I need to multiply the first fraction by x plus 1 over x plus 1. To build up the second fraction to have this denominator, the x plus 2 factor is missing, so I need to multiply by x plus 2 over x plus 2. So if I multiply these two fractions and these two fractions, I'll get a common denominator. So I have x plus 3 times x plus 1 over x plus 2 times x minus 1 times x plus 1. And I have 2 times x plus 2 over x plus 1 times x minus 1 times x plus 2. So what's cool about that now is I have a common denominator. And what I can do is I can work on getting the numerators. And I'm seeing that I made a mistake. So here, this should be x squared plus 4x plus 3 plus 2x plus 4. So that should be a 7. Okay? And so so if you got a 7, you're good. And that means that there would be no other factoring that we can do. So my mistake here, this should be a 3, so we should get a 7 here. So we can ignore the rest of what's going on here. Okay, so just as you have getting to know me as a presenter on videos, sometimes there's a mistake that I've made. So once again, that should be a 3. We'd have a 7 here, and this would be simplified. So just be careful. Be critical of what I do sometimes. Now here's an example where we're subtracting. Same idea. We want to build up, we want to figure out what the denominators are and what the LCD would be of the denominators. So I factored the first denominator into x minus 4 times x minus 2. The second denominator factors into x minus 4 times x plus 3. And so we need an x minus 4, x minus 2, and an x plus 3 for our common denominator. So to build up the first fraction to a common denominator, I need to multiply the first fraction by x plus 3 over x plus 3. To build up the second fraction to the common denominator, I need to multiply by x minus 2 over x minus 2. So if I take 5x times x plus 3 minus 3x times x minus 2, I can write that over the common denominator of x minus 4 times x minus 2 times x plus 3. And I distributed and simplified, so we get 2x squared plus 21x over x minus 4 times x minus 2 times x plus 3. So try this problem, pause the video and come back, and then check your solution with my solution. Hopefully this time I'm doing everything correctly. So here we have, in the first numerator factors to x plus 3 times x minus 1, and the second denominator factors to x plus 3 times x minus 3. So I need an x plus 3, an x minus 1, and an x minus 3. So I did some things a little bit quick here. To build up the first fraction to the least common denominator, I needed to multiply the numerator and denominator by x minus 3. So I do that here. To build up the second fraction to the common denominator, I need to multiply by x minus 1. So I multiplied the x plus 4 over x minus 1, and I wrote that over the common denominator of x plus 3 times x minus 1 times x minus 3. I then FOILed things out, and then I did some subtraction. So when I FOIL out this, I get 3x squared minus 9x minus 1x gives me minus 10x plus 3. And then when I FOIL these out, I get x squared plus 3x minus 4. Now, when I do the subtraction, I'm going to make sure that I distribute the negative to all three of those terms. So I'm going to have 3x squared minus x squared, which is 2x squared. Negative 10x minus 3x gives me the minus 13x. And 3 plus 4, the opposite of negative 4 is 4. 3 plus 4 gives me the 7. And so we get a simplified fraction this way. Okay? So that ends this lesson. Try out the written practice problems and also the online work for this section, and we will see you in class. Take care.